All right, so get this. Today, we're going to deep dive into how robots understand the world around them.
Yeah, just like we do with our own senses.
Exactly. And the source material for today, super cool lecture notes from a course called, get this, Coding for Creative Robotics.
Oh, nice.
I know, right? So we're talking robots that can see
Yeah.
and even, wait for it, react to our thoughts. It's like straight out of sci-fi.
It is pretty wild.
By the end of this deep dive, you'll know how robots translate the world, like everything they see and hear, into data they can use.
And what that means for the future of, well, robots and humans kind of hanging out together.
Exactly. Because let's be real, robots are becoming more and more a part of our everyday lives.
Definitely. So it's like giving them their own set of senses, but instead of eyes and ears, they have all these different sensors to pick up signals.
Signals, like what kind of signals?
We're talking audio, visual, even stuff like brainwaves.
Wait, hold on. Brainwaves. So are we talking about robots reading our minds now?
Well, kind of. But maybe let's back up a bit and start with something a little less, sci-fi.
Okay, yeah, good idea. How about something like sound?
Sure.
Yeah.
Think about those voice assistants everyone uses these days.
Oh, yeah, like the ones in our phones and stuff.
Exactly. So they use these things called microphones to capture those tiny vibrations in the air, sound waves, and then turn them into electrical signals.
Oh, right. And then those electrical signals are what gets turned into, like, the digital stuff a computer can understand, right?
You got it. And the lecture notes actually call it like a digital fingerprint of the sound.
A fingerprint. Interesting. So basically, that fingerprint is what the robot uses to figure out what it's hearing, right?
Precisely. And the same thing happens with cameras, which are basically like a robot's eyes. They capture light and then turn it into images.
Like digital pictures, right?
Yep. It's wild to think about how those images, like the one from the notes, that little 2 by 2 pixel example, are actually just a bunch of numbers representing colors.
Okay, that makes sense. But back to the brainwaves thing for a sec. How do they even capture that? That seems way more complicated than, like, sound or light.
You're telling me. So for that, they use these things called EEG sensors.
E.g.
Yeah, electroencephalography. It's a mouthful. But basically, it's a way to pick up on the electrical activity in your brain.
Whoa. So they can literally see what's going on in our
That's a
heads.
way, yeah. And all that brainwave data could be used for some pretty amazing stuff, like you might have heard of brain-computer interfaces or BCIs.
BCIs. Rings a bell.
So they're being used to control things with, well, your thoughts, like that robotic arm, Joy. Have you heard of that one?
Yeah, the one that's controlled, like, with just your mind.
Yeah, exactly. That's BCI in action. Pretty cool, huh?
That's insane. So we're talking like numbers for colors, numbers for sounds, and now numbers for thoughts.
It's all about translating the world in all its craziness into something a computer can understand, data.
Okay, that's pretty mind-blowing. But it brings up a big question. How does a robot actually take all these different signals, like the sounds, the images, the brain waves, and actually make sense of it all?
Well, that's where we get into the whole world of signal processing.
Signal processing.
It's like a 4-step recipe. First, you've got the sensors grabbing the raw signal. Could be a sound wave, a brain wave, whatever.
Okay, that makes sense.
And then they digitize it. So they're taking those analog signals, which are kind of like, well, waving continuous.
And turning them into ones and zeros, right. So
Yeah.
the computer can actually work with it.
Yeah, exactly. But even then, it's still pretty messy. There's a lot of noise and extra stuff in the signal.
So that's where the processing stage comes in,
You
right?
got it.
Yeah.
It's all about cleaning things up, getting rid of that noise, and finding the good stuff, the important bits of information.
Man, that must be like finding a needle in a haystack.
It can be, but luckily there are all sorts of fancy algorithms and techniques for doing that.
Algorithms, huh?
Yeah.
Always gotta love those.
Oh, yeah, they're the secret sauce. And then finally, once you've got that nice, clean data, there's the interpretation step.
So that's where the robot actually figures out what that data means.
Exactly. Like, hey, that's the sound of my owner's voice telling me to make a sandwich.
And boom, the robot goes and makes you a sandwich.
Well, hopefully that's the goal anyway.
Okay, so we've got the robot sensing the world, processing the data, and then making decisions based on what it understands. But what happens to all that data when the robot, like, shuts down? Does it just disappear?
That's where things get even more interesting. We have to talk about data storage.
Oh, right. Like saving files on a computer.
You got it. So in a robot, there are two main types of memory. There's volatile memory, which is super fast but doesn't last. And then there's persistent storage, which is more like a hard drive.
So volatile memory is kind of like the robot's short-term memory, and files are its long-term memory.
Exactly. And just like with our computers, we need to store that data in files so it can be accessed later.
Makes sense. But why are there so many different types of files? Like, the lecture notes talked about CSV files, JSON files, binary files. It seems kind of confusing.
It can be. Think of each file type as a different kind of container. Like you
Yeah.
wouldn't store soup in a container meant for dry goods, right? It'd be a mess.
Okay, yeah, that makes sense. So you're saying choosing the right file type is about making sure the robot can actually access and use the data efficiently.
Right. It's like putting all the pieces of a puzzle together in the right way so you can see the full picture.
So it's not just about having the data, it's about organizing it and making it useful. Like having a giant library full of books but not knowing how to read.
Exactly. That's where data wrangling comes in.
Data wrangling. Sounds intense.
It's a fancy way of saying that we need to process all that raw data and turn it into something meaningful, something that we can actually use.
Like, what kind of things can we do with that processed data?
Oh, so many things. Like, imagine teaching a robot to recognize emotions from facial expressions,
Mm.
or processing brainwave signals to control a video game with your mind. That's what data wrangling is all about.
Whoa. Those are some seriously cool applications. But how do they actually do that? The lecture notes just mentioned these things called like pandas, OpenCV, Labrosa. What are those exactly?
Those are like specialized toolboxes for data wrangling.
Toolboxes.
Yeah, basically libraries of code that have all these pre-built functions for doing specific things with data.
So instead of having to write all the code from scratch every time, they can just use these pre-made tools.
You got it. It's like having a set of power tools for data. It makes the whole process way faster and more efficient.
That makes sense. So with the right tools, you can unlock some pretty incredible insights from even the most complex data sets. That's pretty amazing.
It is. And we're really just scratching the surface of what's possible. But all this power comes with responsibility. You know, we need to make sure that data is handled responsibly and ethically, especially when we're talking about robots interacting with humans.
Right, because they're not just dealing with numbers anymore, they're dealing with people and potentially sensitive information. We'll definitely have to dive deeper into those ethical considerations later on.
For sure. It's a whole other can of worms.
Yeah, it sounds like it. But for now, we've covered how robots sense the world, how they process all that information, and even how they store it for later use.
Hmm.
Who knew robots had such complex inner lives?
It's pretty mind-blowing when you think about it.
It really is. Okay, so that wraps up our deep dive into how robots sense the world. Next up, we'll be exploring how they actually use all of that data to make decisions and interact with their environment.
Should be fascinating. I can't wait to see what we uncover.
Me neither. So stay tuned, folks, because things are about to get even more interesting. We'll be right back after a short break.